When a program runs on a computer, it is assigned to a process or thread which runs on the computer's processor. Until recent years, most computers only contained a single processor, so there was no benefit to having more than one thread running at the same time. Modern computers often contain 2, 4, or even more processors. By creating multiple threads using the action and task classes, you can divide intensive tasks between the computer's processors, significantly speeding up the tasks. The action and task classes are almost completely new in ASP.NET 4.5. In previous versions of ASP.NET, you would have used the thread or thread pool classes. The task class combines the features of the thread and thread pool classes, making it the ideal choice for multi-threading. Note that an earlier version of the task class did exist in ASP.NET 4.0, but it was extremely limited compared to the version provided in ASP.NET 4.5. I would recommend against using the task class in earlier versions of ASP.NET. To begin this lesson, open the Mathland project from your sample files folder. And view primes.aspx in your web browser. This page calculates prime numbers up to the value specified. It does this by counting backwards and attempting to divide each number by every number below it. This may not be the best way to calculate prime numbers, but it's a good example of a computationally intensive task. Click Calculate Primes to calculate every prime number up to 100,000. Depending on your computer's speed, there may now be a long delay. The calculation took 24 seconds on my computer. The prime numbers are displayed in a list box control. Close your web browser now. And open the code behind file of primes.aspx. Now examine the button Calculate Primes click event handler and find the line Calculate Primes new int to maximum value. This code calls the Calculate Primes method with an int array as an argument. Now examine the Calculate Primes method. This method may look a little strange. Instead of accepting an int array as an argument, it accepts an object argument, and then converts it into an int array on the first line. This is necessary because the task object is only able to work with methods that either have no arguments or have a single object argument. Next, you're going to create a new action argument. First, add the following using line to the top of the code. Using system.threading.tasks. The task and action classes are in the new system.threading.tasks namespace, so this line will make them easier to access. Now in the button Calculate Primes click event handler, replace the line Calculate Primes new int to maximum value with action object calculate primes action equals new action object calculate primes. This code creates a new action object That points to the calculatePrimes method. The action class actually creates a delegate for the calculatePrimes method. You'll learn more about delegates in lesson 4.10. Now add the following code on the next line. Task thread1 equals task.factory.startNew calculatePrimes action new int 2 maximum value divided by 2. This code creates and starts a new thread. Because you only want task 1 to do half of the work, you are telling it to calculate prime numbers from 2 to half of the maximum value. Now add the following code on the next line to create a second thread. Task thread2 equals task.factory.startNew calculatePrimes action new int maximum value divided by 2 plus 1 maximum value. This code creates and starts a second thread, which will calculate the other half of the prime numbers. You might think that this code is now complete, but the code is vulnerable to a terrible form of error known as a race condition. In the next lesson, you'll learn about race conditions and fix this code to prevent one from occurring. Note that it is possible to use the task class without needing an action object. You can do this by using a lambda expression. You've seen lambda expressions when working with LINQ. Here's how this lesson's code would have looked using a lambda expression. This is a very long line of code, but you may find it easier to understand. This syntax can be used anywhere where an action object is required. Close Visual Studio now, saving your changes if prompted. And you've now completed Lesson 3.4. Implement multithreading using the action and task classes.